Hi, in this video we'll be covering states of matter. When it comes to states of matter, there are two types of energy we need to be concerned with. The first one is kinetic energy, and the other one is potential energy. Kinetic energy is energy in motion. This is the type of energy particles have when they move or vibrate, and the faster they move or faster they vibrate, the more kinetic energy they have. Potential energy is stored energy, or like the type of energy stored in a compressed spring. This is the type of energy in chemical bonds. Kinetic energy is related to temperature, while potential energy is not related to temperature. It is instead related to intermolecular forces. Something I want to explain before we start is the difference between intermolecular and intramolecular. So, intermolecular forces are between molecules, while intramolecular forces are within molecules. So the important words to note here are between and within. So here's an example. We see that there are two water molecules, and there are also two different types of bond indicated by the solid line here and the dotted line here. So which is which? We see that this bond is within a molecule, and since it's within a molecule, it's intramolecular. So we write intramolecular. This bond, however, is between these two molecules, and since it's between, it means that it's intermolecular. So we write intermolecular. So the three main states of matter are solid, which is denoted by an S in parentheses, liquid, which is denoted by an L in parentheses, and gas, which is denoted by a G in parentheses. So in a solid, the molecules are quite tightly packed, and the intermolecular forces are strong. So we write strong intermolecular forces. In a liquid, the molecules are more separated, but there are still intermolecular forces. But in a liquid, the molecules or particles can flow around each other, which I will show by these arrows. We can write weaker intermolecular forces. In a gas, the particles are very separated, and they move in something called Brownian motion, which is just random motion. And in a gas, we say that there are no intermolecular forces. The properties of solids are that they have a fixed shape and a fixed volume. The properties of liquids are that they have no fixed shape, but they do have a fixed volume. The properties of gases are that they have no fixed shape, and they have no fixed volume. A final state of matter which is important for chemistry is aqueous state. When matter is in the aqueous state, it means that it's dissolved in water. Since water is a polar solvent, it means that charged particles such as ions are often dissolved and in aqueous state. Aqueous state is denoted by AQ in parentheses. We can now start looking at how matter changes state. So when a solid transitions to a liquid, the process is called melting. And when a liquid transitions to a gas, the process is called boiling. For the reverse processes, when a gas transitions to a liquid, is called condensation. and when a liquid transitions to a solid is called freezing. A solid can also transition directly to a gas, and this process is called sublimation. And a gas can also transition directly to a solid, and this process is called deposition. Lastly, we need to look at how temperature of matter varies when we add energy. So from this graph, we can see that there are 3 places where temperature increases when we add energy, and 2 places where the temperature plateaus. So initially, we add a solid, and then after first plateau, we get a liquid, and then after second plateau, we end up with a gas. So the reason for this is that initially, when we add energy, the energy goes to increasing the kinetic energy of the solid, and since kinetic energy is related to temperature, it will increase the temperature of the solid. But at some point, added energy will stop increasing kinetic energy and instead start removing or breaking the intermolecular forces between the molecules. And when this happens, the state transitions from being a solid to a liquid. So this first plateau is called the melting point. And then after the matter has melted, once again the energy starts to contribute towards kinetic energy. And we can see this since the temperature starts increasing again. And then it would reach a point again where the state transitions from a liquid to a gas. And this is because the added energy will start breaking the last of the intermolecular bonds or intermolecular forces. And since potential energy is not related to temperature, the temperature will not start increasing when we add more energy. And this point is called a boiling point. We have now covered states of matter. In the next episode, we'll cover the mole concept. See you then.